This is the first lesson on the National 5 topic of similarity. In this lesson, we're looking at scale factor. Scale factor. When photographs are enlarged, all lengths need to be increased by the same scale factor. If lengths are multiplied by different scale factors, the image looks distorted and is not a true enlargement. If we look at these first pair of photographs that I've got here, I have my original and I've got a true mathematical enlargement. You can see by looking at all the details in the photographs, it has not been distorted. So both dimensions, its height and its width, have been enlarged and have been enlarged by the same factor. It's been multiplied by the same number. Looking at the second pair, this is not an enlargement. We can see the height and the width have both been made larger in comparison to the original, but just looking at some of the details, you can see that it has been distorted. So it's not a true mathematical enlargement. The scale factor can be calculated by comparing dimensions. To make calculations easier, it's a good idea to leave these as fractions. And that's what I'm going to do throughout these series of lessons. The scale factor is basically how much your shape has been multiplied by to either enlarge it, this is the case in these first two, or reduce it, which is the case in these second two shapes. If I compare these two dimensions, I can form my scale factor. I've said 6 over 4 for my scale factor. I'm basically asking myself, if you think about it, how many times does 4 go into 6? How many times does this dimension go into this? 6 over 4, keeping in mind we need to simplify our fractions, would give us 3 over 2. So the second shape is 3 over 2 times 1.5 times bigger than the first. The second pair of shapes, again, I would put a fraction together by doing the second shape over the first shape, taking this dimension of 2 and writing it over 10. Again, simplifying wherever possible would give me 1 over 5 by dividing the top and bottom of that fraction by 2. We can say a scale factor greater than 1, so the case in these first two here, will enlarge the shape. So multiplying a side by a number greater than 1 will make it bigger. A scale factor less than 1, well, that will reduce the shape. So multiplying a number by anything less than 1 will make it smaller. Once we know the scale factor involved, either in enlargement or reduction, we can find missing dimensions. So, two examples. Calculate the scale factor and the missing dimension for each pair of shapes. So, I will look at this first one. Going from the first to the second shape, I've got an enlargement. So I would expect my scale factor to be greater than 1. I've got the sides 10 and 4. So I can form my fraction 10 over 4. This will give me a number bigger than 1, as my numerator is bigger than my denominator. Simplifying by dividing the top and bottom by 2 would give me 5 over 2. So it means this shape here, if I multiply both of the sides by 5 over 2, will give it these dimensions here. So A, the missing dimension, will be 3 times my scale factor. So I have taken the missing dimension 3 and I have multiplied it by my scale factor. Multiplying 5 times 3 would give me 15, so 15 over 2. Simplifying that down to 7.5 or 7.5. Easier to leave your answer as a decimal or as a mixed number. You could be writing, if you wished, 7.5, just because that's a bit easier to visualize than 15 over 2. second set of shapes. Again, I've got a reduction. The second shape is a reduction of the first shape. I've got a pair of sides that match up. I can compare the heights. So I can put together a fraction 5 over 12.5. A bit trickier to simplify. Rather than trying to make them smaller, if I double the top and bottom, so times the top by 2 and times the bottom by 2, it would give me 10 over 25. Get rid of that horrible decimal on the bottom. Again, both of these could be divided by 5, giving me a scale factor of 2/5. So 2/5 being less than 1, which reinforces the fact this is a reduction. So I know B is going to be 2/5 the size of 4. So I need to take 4 and multiply it by my scale factor of 2/5. 2 times 4 would give me 8. So I have 8 over 5. Again, a bit hard to visualize that. Either, depending on how good you are with your fractions and decimals, you might be able to convert that straight away. But I could say, how many times does 5 go into 8? Well, it goes once, put a point 0, so I can put my remainder 3 down. 5 goes into 30 6 times, giving me a missing dimension for B of 1.6 centimetres.